with example of Wi-Fi web server from files, examples, into ESP8266 Wi-Fi, into Wi-Fi web server. Okay, so watching this video, you will come to know how ESP8266 can act as a local web server that will be responding web pages according to the request coming from the client side. Then you will come to know how to create a web server at HTTP port and also at other port as per your choices and interact at that port also. You come to know how to get the Wi-Fi server instance in the Wi-Fi server class. You will also come to know how to control or interact with appliances or with LEDs using a web interface or using a web page. So this all and many other things you will come to know by watching this full video. So let's get started. Okay, so this is an example, and luckily this example is well explained or well commented, so I don't need to edit this. I don't need to make any another code for this, but still, if in case I need to comment in between, I will definitely do the comment and will upload this code into my GitHub account. So starting with the first line, which is the ESP8266 Wi-Fi.h, so only single header file we need to include for this example, and the SID name and password I need to write here as SMS and SMS 123458955, which I think everybody now must be knowing, and my neighbors will try to connect this hotspots if they are watching this video. Okay, so before that, let me tell you the difference between three codes, which is Wi-Fi WebServer, Wi-Fi access point, and Wi-Fi telnet to serial. So all the examples are covered. This is the last example of this Wi-Fi ESP8266 Wi-Fi examples. So in the previous example, in Wi-Fi telnet to serial, what we were doing is we were interacting through text messages from a server to client. So there will be a client-server interaction via text messages using the local port 23, which is a default port for telnet. Now, difference between the telnet and this Wi-Fi web server is we can even interact with Wi-Fi web server and we can even interact with telnet to serial protocol. The difference is we can only do the text-based communication on that telnet, while in this we can even send HTML pages and all the stuff. This is the basic difference between telnet to serial and this Wi-Fi web server. And now the difference between Wi-Fi web server and Wi-Fi access point was that both the examples are similarly written, or in both the example we can send the web pages according to the request coming from the client side. So what's the basic difference between them? So difference between these two codes is in Wi-Fi access point there is no role of intermediate router. There is no role of that any router, because ESP8266 itself was acting as an access point to which all other clients will be connected. So there will be a host and password particularly for the ESP8266, and we need to enter that name and password in other clients to get connected to that ESP server. So there is no role of router in that. But in this particular web server, what's happening is that first ESP8266 will connect to a router, and router will assign a local IP address to this board. And using that local IP address, we can interact or we can communicate with this ESP8266 server. So this is the basic difference between this web server and that access point example. Okay, so same function, same application, but two different procedures. So if anyone asks me that choose one from Wi-Fi web server and Wi-Fi access point, I will definitely go for Wi-Fi access point, because there is not at all any role of router in that. So that can be regarded as a standalone server. So that example I will prefer to have in my particular project. But still, it's my role to explain all the examples. I will be explaining this example also. This is the same as the Wi-Fi access point, but still. So okay, so here we are declaring the server instance is a Wi-Fi server class at the port 80. Now this port 80 is for the HTTP, which is, if you have watched the videos, you must be knowing that this is the default port for HTTP based communication. So with this we can interact with the server using our web browser. So hence it is written as port 80, but we can convert this example into telnet Wi-Fi to serial by just changing this port. If we change this port to any other port, we can interact with this ESP board using the telnet client application on our smartphone. I will be letting you know how to do that also. First of all, we will be interacting with the web browser, then we will be changing the port and we will interact with the telnet Wi-Fi to serial or telnet application on my smartphone. So moving ahead, we have the default baud rate serial 500 declared here, and the serial communication is begin. After that, a delay of 10 milliseconds, which is not at all useful. Then the pin mode 2 as output, the GPIO2 here is declared as output, because so in this example what they are doing is they are waiting for the client to send or request a particular link in their web browser, and if that particular link is you can say observed by ESP8266, then it will toggle the LED according to the request. Then we will see what are the requests based on which they are toggling the LED. We will see it further. So after that, it is showing that connecting to a particular SSID, which is name is returned already above. After that, this function Wi-Fi.begin. This Wi-Fi.begin function is used to let ESP8266 get connected to your host. By entering the host name and password, you can just get connected with that router, and if it gets connected, the status of the Wi-Fi.status function will change into WL_connected. So we are pulling this function until unless it gets WL_connected. We are just waiting inside the while loop, and as soon as it gets connected, the status will get changed and will jump out of this loop and will show at Wi-Fi connected. And here we are beginning the server at this local IP address assigned by our router, and the local IP address can be found by this simple function called Wi-Fi.localIP. Okay, so this is the setup. Now starting from the loop, we have client instance declared in the Wi-Fi client class, and the Wi-Fi client class, and it is checking if there is a client available, or is there any client want to connect with this ESP board. This can be observed by this function called server.available. Now server is nothing but the instance declared for Wi-Fi server. Here it is declared. So we are just checking if there is any client available to get connected with the ESP server. If there is no client, it will return. So it will just start from here. It will just be stuck in this loop only if there is no client. As soon as any client gets connected, it will print as new client. Okay, so what this while loop about? If the client not available, if not of client not available, because means that if there is nothing from the client side available to the server, then wait inside this while loop only. Do nothing until and unless there is something coming from the client side. So as soon as we request something from the client side, it will save that string. So remember one thing, the request coming from the web server or the client side will be always in a form of a string. So what we are doing is we are reading the string from the client side. So the function is client.read string until the carriage return function. So the last character will be of carriage return. So we are just polling that character, and up to that character we will be reading out our whole string, and we will store in a local variable called REQ, which is request. And we will be printing the request on a serial monitor. The client.flush function, what will this function will do? This function will just clear out the buffer. So what happens is that whenever we are sending the data to the client, first of all it is stored in a buffer, and whenever receiving the data from the client, also it is stored in the buffer. So this client.flush function is just to clear that buffer. When this function need to be used, whenever we need to send the data, then after sending the data we need to use client.flush, and after receiving the data we need to use client.flush as to clear out that buffer. After that, we are just polling. This variable is declared. This is used after where. Okay, this is variable is declared just to initialize the value of the LED. So we will be seeing it further. Now, request.index of. Okay, what this request.index of function will do? This will just check the chunk of data. Is the data available from the whole string? Is there something called /GPIO /0 in the whole string? If yes, then this function will become true, and the value of the variable called value will become 0, and if something called /GPIO/1 is available in the whole string, the value of the variable VAL will turn to 1. So according to our request, the LED will be turned off. So if we are sending 0, it will be turning off. If we are sending 1, the LED will be turned on. And if there is nothing of like /GPIO/0 or /1, we will be just printing that invalid request, and we will stop that client. And this return function will jump our code again to start from the main loop. Okay, so if we are receiving any one of 0 or 1, the code will come here and will just write or just change the status of the LED according to the request received. And after that, will again client.flush issues, but I don't think this is much useful here because this is used only when we are receiving or sending the data. So just comment it out, no worry. And after changing the LED, we are just sending some feedback to the, what we can say, client that we have received something from your side. So what we are sending is that HTTP 1.1 200 OK request. Now 200 code is for the successful communication. So we will just sending 200 OK. Content type is simple text HTML. And after that we are sending HTML page in which it is written as GPIO is now. Okay, so what is this function means? So particularly this is the format in which this function is written. There is first of all there's a condition. The condition can have two response or two output, either true, either false. So if this condition is true, give the response as high. If this condition is false, give the response as low. So same thing is happening here. If the value is 1 and true are the same. So if value is 1, that is true, then send high to S, and if this value is 0 or false, send low to this S. So this is a simple logic we have used to send high or low to that client side. And after that they are closing this HTML. So they have created just an HTML page which will be given in response to the client. And after that we are using the client.print s, and here we need to use that client.flush to clear out the buffer. Okay, so after the delay of 1 second, we are printing that client is disconnected. Okay, so here also we need to write as client.stop, because we need to stop the communication after that. So this is the code. Let's just upload this code and see what happens. Okay, let's just open the serial monitor and let's see the response. Connecting to SMS, it's connecting to my router. It is connected, server started at local IP 192.168.43.173. So I will just connect my phone to the same router to which ESP8266 is connected, and we'll just open the Google Chrome or any browser, and we'll just request this link with /GPIO/0 or /GPIO/1. So delete it. So it is 192.168.43.173 / I need to look at the format. Yes. Okay. /GPIO/0. So just request and just look at this LED. Okay, it is shown as a new client and get the GPIO 0 and client disconnected. So it is written as GPIO 0, GPIO is now low. So this is a reverse logic. Sorry, I need to turn it to 1. Let's see what happens. So basically this is a LED which is reverse logic. So on which is active low LED. On receiving 0 it will be turning on, and if receiving 1 it will be turning off. So I will again send the GPIO/0, it will turn on and it is written as GPIO low, and if I send GPIO/1 it will turning off and it is written as GPIO is now high. So this is basic communication between this client and this server using this Wi-Fi web server example. Now let's change the code. Now we will change the code here and we'll be communicating using text-based communication which we are doing on telnet to serial. So I will just change the port here. Change to 5000. Remember one thing, whenever you are using a random port, use the port which is about 2000 or 3000 maybe, or likewise the higher values of port you must use, because all the lower values are assigned to some or other protocols. So it's better to go for 5000 for 8888 or for higher values of port. So that these are some ports which are not at all used for any of the default. This port are some of the ports which are not at all default for any protocols. They are open to use by anyone. So I changed the port to 5000, so it won't be now used by the HTTP or won't be used by the browsers. And now I will just delete this much of code. I will be deleting this also. Okay. So client.print hello world. So it will just print hello world on the client side. It will flush and the client will be stopped after every second. And it will be reading for the client also. Okay, it doesn't matter. Let's just upload and see what happens. I need to open the telnet example for that, a telnet application. .192.168.43.173 and the port here is 5000. Let's just finish uploading this code. Okay, open serial monitor, connecting to SMS, disconnected. Let's just connect to that port. Okay, it shows new client, and I just send something. Let us send hi there. Okay, it has received hi there and just got disconnected. Why so? Must need to send. Okay, it shows client.stop, that's why. X, and after 5 seconds it should be printing as client.stop. Let's just upload now. So I think this must be like that. First of all, we will send some data, it will receive, and after that we will be sending the hello world, and after 5 seconds this connection will be stopped. So let's see if this happens or not. I will again type that same IP address 192.168.43.173 and the port is 5000. So this is basically a machine to machine talk. This is definitely a machine to machine talk. This is a what is a phone. Let's just see the example. After that we will talk. So it is started. I will connect. There's a new client and I will just send hi there. And as you can see that I got the hello world, and after 5 seconds this connection will be stopped. Yeah, this is stopped and client disconnected. So basically this is a machine to machine talk. It doesn't look like that because we are not at all utilizing this concept or utilizing this machine to machine talk. Just we are chatting with each other. Here we have used the phone, but we can even use another ESP board which is on the any side which is connected with the bulb, and which can talk to our main server, and you can just give the feedback. Yeah, the bulb is still on, or the bulb is on, or bulb may I turn the bulb off, or if I attach the temperature sensor then to the fan, that they can give the feedback. The temperature is now 35. Should I turn off the fan or turn on the fan? So the server can respond, yeah, turn it on. Then it will just turn on the fan. So this is basically a machine to machine talk. I am planning to make a project on this M2M, and will soon uploading that project as I get a much clear idea about how to present this talk much better and a much easier way as possible. So ending this video here, this is a basic example of Wi-Fi web server. I hope you got the idea about what is this example about and what the application, because I have totally changed the scenario on how this example was written. So I think you must got the basic idea on how you can modify this example according to your application. So this is all for this video. Subscribe my channel for upcoming videos of this tutorial series. Till then, explore and share with me, techiesms.